Cracking is a process used in petroleum refining to convert medium and long-chain hydrocarbons into short-chain hydrocarbons. This is necessary because the market demands more short-chain hydrocarbons than are found in crude oil, while the use of long-chain hydrocarbons is declining. In the following, I will show you how to conduct the cracking process on a home lab scale. I'm not a big fan of standard lab stands, so I often use aluminium extrusions, pipe clamps and a cutting board as a base plate for my experiments. Don't worry if you don't understand what I'm building here yet. I will show you an animation of the entire setup in a minute. Since you need bromine water as a reagent and it's easy to produce through electrolysis, I built an electrolysis cell. For the experiment we need the following chemicals. And here's the promised animation. Suppose that in a carbon chain of a hexane molecule, a bond between two carbon atoms breaks due to the effect of heat. In that case, the electron pair that previously held the two atoms together is separated at the point of breakage. Each of the two carbon atoms involved now forms an additional bond with its neighbor in the carbon chain, thereby releasing two hydrogen atoms. These hydrogen atoms combine to form a molecule. All in all, the process can be described as follows. Through cracking the saturated hydrocarbon hexane, an alkane is converted into hydrogen, ethene and 1-butene, two unsaturated hydrocarbons, or more precisely, two alkenes with shorter chains. First, we prepare the electrolyte. To do this, we weigh out 24 grams of potassium bromide. Using distilled water, we prepare a solution of 200 milliliters, which corresponds to 1 mole per liter. Now 70 milliliters of paraffin oil is added to the round bottom flask. When adding the catalyst, make sure it covers almost all of the liquid. The purpose of the bromine water is to detect alkenes. Alkenes are relatively unstable. For example, when ethene is fed into bromine water, the bromine reacts with ethene in an addition reaction to form 1,2-dibromoethane. So if alkenes are present, the bromine water becomes colorless once all the bromine has been consumed. Before we begin the cracking process, it is recommended to purge the system with argon to remove all oxygen. The experiment can now begin by heating the paraffin oil catalyst mixture. A strong smell of natural gas spreads throughout the lab. The catalyst turned black. Two phases had formed in the gas washing bottle. As soon as I opened the gas washing bottle, the smell of gasoline hit me. The U-shaped tube was full of condensate and also smelled like gasoline. What the hell? All of the collected products were then transferred to a separating funnel, where the phases were, well, separated. Next, the volume and the weight were measured. Let's do a flammability test. The paraffin oil would not ignite. However, the products could be ignited, so a non-flammable oily liquid remained. Finally, the products were transferred to a flask for fractional distillation and further analysis. If you are interested, I will make a separate video about it. Thanks for watching. Stay true, stay you.